Okay, good morning, ladies and gentlemen. This is Professor David J. De Los Reyes. Okay, the date for today is January 3, 2024. It's New Year. Okay, my topic for this morning will be a continuation of my long video format topic trigonometry, and I will be continuing this one. And we are now on lesson number 44. Okay, let's proceed. The topic for this morning will be a long video format. Trigonometry, lesson number 44, and the title of the topic will be the so-called Sine Law. Sine Law is I-N-E, meaning it's actually the one of the concept of a solution of an oblique triangle. It is the so-called sine law. Okay, one of the concept on how to compute problems under oblique triangles is actually the so-called sine law. Okay, let's proceed. Before I will derive the general equation and how to bring out the equation for sine law, okay, I would like to read first what is sine law. Sine law, it is something like this. In any triangle, okay, the sides are proportional to the sides. The sides, okay, are proportional to the sides of the opposite angles. Proportional. In terms of an equation, it will be something like this. If this is angle alpha, the side opposite this one will be side A, and if this is angle beta, the side opposite this one will be small letter b, side letter b, this one. And if the greatest angle here is gamma, the side opposite this one is side C. So if we try to relate sine law in terms of an equation with this given configuration or designations, it will be something like this. Meaning side A all over sine of alpha should be equal to side B all over sine of beta, and this should be equal to side C all over sine of omega. O gamma, this is gamma. Okay? A is actually the side opposite angle alpha, and the small letter b is actually the side opposite angle beta, and side C is actually the side opposite angle gamma. That's sine law. Okay? They are proportional, meaning the ratio of A over sine of alpha should be equal to B over sine of beta, and this should be equal to C over sine of gamma. That is sine law. Okay? In the so-called solution of problems involving oblique triangles, actually, this is specifically true for oblique triangles. Oblique or obtuse. This is or obtuse. Okay? If the given triangle is oblique or obtuse, meaning the triangle is not a right triangle, it is obtuse, meaning the summation of alpha plus beta plus gamma is equal to 180 degrees. Okay? If the summation of alpha plus beta plus gamma is equal to 180 degrees, it is an oblique triangle or an obtuse triangle. The configuration will be something like this. For the meantime, forget the one with the dotted line. So the triangle designation, this one here, first side, this is the second side, and this is the third side. And the given interior angles are actually alpha, beta, and gamma. For this triangle to be oblique or obtuse, the sum of alpha plus beta plus gamma should be equal to 180 degrees. So in here, we are not talking right triangle. We are talking oblique triangle or obtuse triangle, that is the summation of all the interior angles, that is alpha plus beta plus gamma, is equal to 180 degrees. Because if the summation of alpha plus beta plus gamma, okay, if this should be equal to, this is still equal to 180 degrees, but under the so-called right triangle, the summation of the two interior angles, including the 90 degrees, is still 180. For a right triangle, this will become equal to 90 degrees, right? So if we are considering obtuse, just think of it that the summation of alpha plus beta plus gamma is equal to 180 degrees. It's not a right triangle, okay? Or that's the so-called red flag for it to be an obtuse or oblique triangle. The summation of alpha plus beta plus gamma is equal to 180 degrees. For it to be an oblique or obtuse triangle, okay, so we could use the so-called sine law. Okay, let's proceed with the so-called derivation of this one. How come for a sine law, the ratio of A over sine of alpha plus sine B over sine of beta is equal to sine C over sine of gamma. These are opposite side in angles, opposite side in angles, opposite side in angles. Okay, let's proceed. What I will do here, I will extend this one here. So this should be a dotted line. And I will extend this one also upright. So this is a horizontal line, this is a vertical line. So in here, this angle here is 90 degrees. So it seems, if we try to forget this one here, we are having a right triangle, right? So our knowledge on this whole study of right triangle, we could apply it here. Okay? So I will designate this one as H. Okay? And this one, we do not need to place a designation here. Okay, let's try to bring out two right triangles emanating from this one. The first one will be this. Where is that? It is this. This is H. This is side C. And this is angle alpha. So it seems we brought out this one, the bigger one. That's the first right triangle. The second right triangle that emanates from this triangle here is actually this portion here, the smaller one. So this is still H. Okay, this side here, we do not have to place a designation. This angle here will be one. If this is gamma, this angle here should be 180 minus gamma, right? Because this is a horizontal line. If this is gamma, this angle here will be 180 degrees minus gamma, this one. Right? And this side here will be side A. This is side A. So this is side A, this is side C. This is angle alpha, this is 180 degrees minus gamma. And from these resulting right triangles, we will be formulating an equation in which to derive the so-called sine law. So from the first right triangle, if we try to take the sine of alpha, we are now talking right triangle here, but we are on the topic oblique triangle. It is just that we brought out right triangles from the oblique triangles, right? So if we try to take the sine of alpha, it will be, from our study of the values of trigonometric functions, sine is actually opposite, okay, over hypotenuse, right? So sine of alpha will be h over c, okay? And if we try to compute for h, H will be C sine of alpha. We call that equation number 1. So this equation here emanates from the first right triangle that emanates from the oblique triangle. Okay? For the second right triangle, also that emanates from this, if we try to take the sine of 180 degrees minus gamma, the definition is still opposite of what I just said. Considering 180 degrees minus gamma, this is opposite. Okay, this is hypotenuse. So if we try to take the sine of this, it will still be h over a. Okay, so sine of 180 degrees minus gamma is actually h over a, coming from this. Then if we try to compute for small letter h, this h here is same as this one, right? So small letter h will be equal to a sine of the quantity 180 degrees minus gamma. Okay? This one here is a complicated one. This is similar to the form sine of the quantity a minus b. Right? We passed by that one, the so-called expansion of the sine of the sum, a difference of two angles, right? And we know how to expand that one. Like what I said, sine of the quantity a minus b, it will be sin cos cosine, or sine cosine cosine sine, right? So if we try to expand this one, it will be sine of 180 cosine of gamma. Okay, if this is minus, this should be minus under the sine expansion. So this is minus cosine of 180 sine of gamma. This one here emanates from the expansion of this one, in which it is the so-called sine of the difference of two angles. Okay, we pass by that one. That's why before we proceed with the study of oblique triangles, we pass by the expansion of this one, because we needed the expansion of this one to simplify this one. Okay, simplifying, this will be a open bracket. Sine of 180 is a 180 is a horizontal line, and sine is actually 0. Okay, it got no vertical component. Cosine of gamma minus cosine of 180. Cosine of 180, cosine of 0 is actually 1, but 180 is on the opposite side, so the value will be negative 1. Okay, and if you don't believe it, just display 180 here. Hold on. 180, you'll take the cosine of this one, it's negative 1. Okay, but for me, I know that the cosine of 180 is negative 1. Right? So this will be negative 1 times sine of gamma. So simplifying further, this is a times open bracket. 0 times cosine of gamma will be 0. A negative and a negative will now be plus. Okay? And 1 times sine of gamma will be sine of gamma. Close bracket. So h now, if we try to simplify, this is now 0, right? So it seems we are multiplying a multiplied by sine of gamma. So after the so-called expansion of this one and simplification, what comes out is h will be a sine of gamma. We call this equation number 2. Okay? So it seems from the second equation, it is a complicated thing, but since we know how to expand the sine of a difference of two angles, it now become a will be equal to a sine of gamma, and this will be equation number 2. Okay? Equating h is equal to h, meaning we equate equation number 1 equal to equation number 2, because the h being mentioned in equation number 1 is the same as this one. So we equate their values. So using equation number 1, the value is c sine of alpha, right? And this should be equal to the value of h using equation number 2, which is the same h. It will be small letter a sine of gamma. So we rewrite this one, and to arrive at this, we multiply all the terms by the reciprocal of sine of alpha and sine of gamma. So this is 1 over sine of alpha, sine of gamma, close bracket. Then we try to expand. C sine of alpha times 1 over this will be C sine of alpha over sine of alpha sine of gamma equal to A sine of gamma over sine of alpha sine of gamma. Then try to make some cancellations. This is where some students made mistakes. As long as the operation on both the numerator and denominator are multiplication, we are free to cancel, right? So this sine of alpha here, the operation on the numerator is multiplication, C sine of alpha. If this is a plus, that's a different story. But since the operation is multiplication, we can cancel sine of alpha with sine of alpha. Again, on the right hand side, the operation on both the numerator and denominator are actually multiplication. So actually we could cancel similar terms. And this sine of alpha here, or gamma rather, cancel with this. Right? The operation is multiplication. It is not addition or subtraction. It should be multiplication for us to cancel. Right? So simplifying, this will be C over sine of gamma equal to A over sine of alpha. So in general now, the so-called sine law will be something like this. A over sine of alpha, okay? We now include sine of beta in A and B. It should be equal to B over sine of beta, and this should be equal to C sine of gamma. Actually, this is the first one we formulated. This is, right? But we include the second angle in sides now. It will be small letter b over sine of beta equal to small letter c sine of gamma. And this is the so-called sine law. So there could be a time that we will be solving an oblique or obtuse triangle, and the solution that will be used will be the so-called sine law. Okay, that's it, guys. That is sine law. Okay, I will repeat it before we will go with this morning. In general, in any oblique triangle, A over sine of alpha should be equal to B over sine of beta, and C equal to sine of omega. This alpha here corresponds to A, and this beta here corresponds to small letter b, and this gamma here corresponds to side C. They are opposite angle in sides, right? So if we refer to gamma, it should be side C. If we refer to beta, it should be side B. If we refer to alpha, it should be side A. So in the formulation of sine law, okay, we should look our figure. It should be A over sine of alpha equal to B over sine of beta, and this should be equal to C sine of gamma. Okay, that's it, guys. So for those of you who would like to watch my channel, for those new viewers, my channel is at youtube.com/@prof.david.j.de. And if you want to share it, please click share. Good morning from Los Angeles. This is Professor David J.